All right, what's up, guys? Mr. Adams did not talk well about this last time. Then I just made this video and didn't do a good job again, so I'm doing it for a third time. All right, so here are different sorting algorithms. This one, we're going to do selection sort first. Okay, so selection sort, it finds the smallest, okay, and then it swaps out whatever the next one is with the smallest. So right now, it's going to go through all of these, and it's each time it finds a smaller one, it's going to turn it red. So right now, 94 is my smallest. I paused it right here, so 67 is the new smallest there. And so it's going to go through this whole step here, and we'll play, and we'll go. See, so now it's 43 is the smallest, and 20 will turn red here in a second, because it's the smallest, okay? And then it goes through, and this is, no, wait, 11's the smallest. And we'll speed up just a wee bit here. We'll speed up quite a bit. And then it sees 3 is the smallest, and then 4, and then 2 there. And once it gets to 2, I'll slow it down again. All right, now it checks the rest of these because it's not 100% sure. And then once it does, it's going to swap the 2 and the 94. All right. Okay. And now we do the whole thing again. So we start here. 43 is the smallest. No, wait, 20 is the smallest. No, wait, 11 is the smallest. No, wait, 8. No, wait, 3. And it goes through the whole list every single time. All right. Boom, boom, boom. All right. And so it doesn't know it has to go through the list every single time. So it goes through once, goes through twice. Now, technically, that means since it goes through the list once, that's n. And then since I don't have to look at this, it's going to be n minus 1 divided by 2. But when you have really, 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 really big numbers, computer scientists just ignore the n minus 1 divided by 2, and they say that's n as well. So the big O, the longest it's going to take is however long it takes to look one of these, it's going to be n squared of that, or how many numbers there are. So how many numbers there are, just count that as how many times you have to look at it. So you have to look at all the numbers n times n. So that would be n squared times. All right. So big O notation, which my professor says they're going to talk about a lot, or that's in job interviews a lot. Like, well, what's the big O of selection sort? And you're supposed to know that. I'm kind of nervous. Well, I don't think I'll ever have one of those job interviews, but kind of scary sounding. So anyway, so the big O, the idea here is that worst case scenario, I have to look at every single number twice. All right. And I know that you don't have to look at every single number twice. And in a small thing, that matters a lot. But in a really, 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 really big one, then the n minus 1 divided by 2 is the exact same thing as n in their mind. Okay. So it's like, well, I got, 2 billion numbers. It's not that much different than 1 billion. So yeah. All right. So I find the smallest number, and then I swap this out. So 43, and I think we're on 17 now. 43 and 17 will swap. All right, we can speed this up. Boom. All right, so each time, and then I swap. And then so 36 now is probably going to be swapped, or that's the one we switched. All right, so we go through it, bam, and we're swapping each time. So that is selection sort. Okay, so I select, and then I swap, select, and I swap, select, and I swap. All right. Loop. All right. Then I guess we'll go. I don't know. I feel like I wish I could bump this up a little bit more. I think we get it though, right? So we'll skip forward there. Boom, there, we're done. See the magic. All right. So then the next one was insertion sort. And in my mind, let's randomize it here. Oh yeah, there's randomizer right there. Okay. Insertion sort. Okay. Now we gotta do it again. Hold on. We're just gonna hit refresh here. Okay. Then I'll change the animation speed. I think this should be called something else, because really you're not inserting, because I thought, you pick it up, put it somewhere else, but that's not it. You're going to swap, okay? So you're going to look at these two, the 50 and the 12, and you're going to say which one of these is smaller, or probably bigger actually. Which one of these is bigger? And then you're going to put the bigger one on the right. Then you're going to go to the next thing. You're going to say which one of these is bigger, and then you're going to put the bigger one on the right, and then you check this one again. All right. So here we go. Insertion sort. I look at these two. I swap them. I combine these two. swap, and then I compare those two, and that's fine. So now compare these two, swap, compare these two, swap, compare these two, swap. Okay, so then these two, well, those two were good, so I didn't care. So swap again, swap again. I'm not, oh, I didn't have to check those two because I knew. All right, so then we go through all the steps. Boom, boom. Oh, don't have to check anymore. Okay, so I swap each time, and then here I'm going to swap several. I'll stop here. I know that the 8 and 12 are in order, so I'm not going to look at those again. Okay, so once again, I'm looking at each one of these at least one time, right? Then the next time, I only have to look at half of them minus 1, or almost. Uh, uh, take the number minus 1 and then divide by 2. Okay, so I only need to look at half of them again, but once again, it's a really, really huge number. You don't care about that. So the big O of this is also n squared. So long story short, if you're going to do selection sort, insertion sort's just as good. It doesn't matter. They should be the exact same. All right. Changing the order of the numbers does actually matter because you're going to compare each time. So if it's backwards in order, and I wish I could do that. I think you can do that somewhere, but we could look. It's going to be more steps. But when you talk about big O, you always look at the worst case scenario. All right. So we go through, we check, we swap, and then sometimes you don't have to move as far. Once we get to these guys, they're kind of already in order. So going through, we'll speed this up. Bloop, 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 bloop. All right, so once again, selection sort is I find the smallest, swap it with the one that's in that spot. Insertion sort, I actually compare each time. So I would call it comparison sort, but I guess they're all comparison. So I'm looking at the ones next to each other, and then I move, and I know I don't have to look at every single one of them, so I can stop there. All right, okay. I think it's going to be on test once again, but big O, and maybe I didn't even say what big O was. Big O is basically the absolute positively longest it's going to take to do something. So if you look, it's going to be the longest absolutely taken in my class. One class I took, I had to memorize all of them, and I've forgot them all since. That is the downfall of being old. All right, so we flip flop those. Zip, see that 10's got a lot of flipping. All right, and so that is why this has big O of n squared, is because I have to look at every number. I need to look at most numbers twice. All right, if it's already in order, I don't have to do that. Like this 2, I'm going to have to do a lot. The 92, not so much, but this 2, going to be a lot of looking. So we'll zip this up. Boom. We'll find the 2. All right, so on average, insertion and selection sort, exactly the same. All right. I think if it's mostly sorted already, I'm pretty sure selection sort works better because you're only moving one number. So like that 2, I was just moving that 2. And so a lot of it has to do with moving things, which I don't think we have to worry about. All right. Okay. So now, new things. I should be giving you a test on this, and I'm probably going to be upset with myself. But anyway, we're going to mush all 3 of the array tests together. So I realize it's going to be a giant test, but I'm going to give you a lot of review. I feel like this is a big part of the test, perhaps. So we're going to do that. So today you guys are going to do 2D arrays, and they're actually crazy easy. Basically, long story short, it's an array in 2Ds. So it is not hard at all. I'm going to have you guys do all 2.8.1. So you're going to do day 1 and day 2 and the ASCII challenge here. So you're going to make something fun, and that'll be cool. All right. So give me a screenshot of your fun owl. Oh, on this, you're supposed to change the 0 to things. Don't just go in here and change these at signs. That is not what it's saying. You have to write something. Type in a. It actually gives you a hint down there. When you write the order, it tells you what you need to do. Okay. Alrighty. So yeah. So you're gonna do both of those, and you're gonna give me a shot of your super sweet ASCII picture, and it'll be fun. That's kind of nice. Alrighty? Okay. Oh, I guess last thing about this, though, just to make sure you guys get this part. Okay? When I assign it, I can assign it by rows. So this is the first row, then this is the second row. If I wanted to add another row, okay? And then so then the columns kind of follow just by being obvious that the columns are there. All right. Okay. I should see. Well, it doesn't quite work. The one person that's in my robotics class, our robotics thing works similar to this, except we have a 1D array that we have a 2D array that we've treated as a one-dimensional array. So anyway, that's not what Java does. You'll get it from the reading. Okay? All right, let me know if you got questions. All right. Bye.